Here are some more videos from our stair building education series. Let's go ahead and get started with our first video. In this video, we're going to take a look at building a guardrail for a set of winder stairs on the inside. I'm going to do another video later on the outside if I get enough interest in this video. So let's go ahead and jump right into it with our first example where we take a line. Remember, the guardrail can be taller. It just cannot be shorter than the minimum size height in your area. And that could be anywhere between 36 and 42 inches. Where I live in Southern California, it's usually going to be 42 inches minimum height for a guard railing. And if I want the guardrail to have a straight line at the top, I can just simply connect the dots here. I can go from this point to this point. And I can basically do the same thing for the upper handrail. So again, I'm focusing on this point here. And in the upper handrail, I'm going to be focusing on this point here. However, I'm going to provide you with a couple of different examples if you want to do it a little differently. If you don't mind breaking up your straight line into two separate straight lines instead of one straight line at the top. And if you notice I didn't connect it to here, that's because I went ahead and connected it to the top line that I'm going to keep straight. Again, I can take and manipulate these lines. However, I'm not a big fan of doing that. And you'll get a better idea of what I'm talking about a little further into the video. So in this example here, I have a straight line going to a line that's going to dip down a little bit and then continue to be straight down here. And I can go ahead and change that to where I have this one here dipping down. In the same way, this one here is going up. Or I can go ahead and change that to where we have a straight line on the bottom and then we have two separate straight lines in the upper guard railing. And let's go ahead and zoom in on that to give you a better idea of what we're doing. And remember, the minimum distance is going to be measured from the front of the step. So as long as your lines connect to the front of each step or are higher, you're not going to have a problem. Higher here, connecting to the front of the step here, and then a little higher here, and then connecting to the front top corner of the steps the rest of the way up the stairway. So I hope that makes sense, because now we're going to go ahead and add 42 inches to the lines that we've created down here to create the top of our guard railing. So again, straight line from this point to this point, and then we're going to have a couple of different lines here to provide you with an example of what this is going to look like after we frame it with 2x4s and install drywall on both sides of the guard railing. So we're going to have about a 4.5 inch wide wall here with a straight guardrail at the top of the lower section, and then we have a little funky dip here. And believe it or not, I've never came across a situation like this. The upper guardrails are always straight all the way through, just like this one here. However, I needed to provide you with an example of it in this video so that I could go ahead and change it and make it straight here. And of course, I think this looks a lot better and should provide you with a guardrail that will meet building codes that have a minimum distance of 42 inches from the front of the steps with a vertical measurement up to the top of the guard railing. In this video, I will be providing you with a method that is very simple to use to calculate the length of the individual step for an angled stair stringer. And if you need more information about laying out stair stringers or building stairs, make sure you go to our website and check out some of our books. So the first thing you're going to want to do will be to lay out the individual tread depth in sections like I have here on the floor or building foundation. So here I have 5 spaced lines 11 inches apart. Then we're going to lay out the lines representing the stringer location on the floor for our angled stringer. And I'm not going to go into a lot of detail here because there's a good chance the angle of your stair stringer is going to be different than the one I have in this example. Then we're going to take the width of the stair stringer lumber. In our example, we're going to be using a 2x12. That's going to be 1.5 inches wide. And that would look something like this if we zoomed in at the bottom, or something like this when we zoom in at the other side. Then we're going to create 2 straight lines. We're going to connect the dots here from this side to this side, and then from this side here to this side here. And you can use one line if you think it's going to work for your project. However, for those of you doing this for the first time, I think it'll be better to use 2 lines to eliminate some of the confusion. Next thing, you can grab a speed square and use it to calculate the angle of the stringer. And this will also be the angle of the risers that you can use to cut the stair stringer. Then all you need to do will be to simply grab your measuring tape and measure the distance. That's it. It's that simple. Then you can transfer that measurement to your framing square and use that to lay out the stair stringers. And I would recommend laying out the stair stringer on the side that you can use the circular saw or whatever saw you're going to be using to make the cut. So hopefully that makes sense and will not be too difficult. And like I said, if you need more information about laying out stair stringers, I do have books at our website that will provide you with all the information you need to lay out a variety of different stair stringers. First up on the list, and probably the most important if you are using building plans, that would be to verify all of the measurements. And I know that sounds like a no-brainer. Oh yeah, that's right. You know, or it might sound like, wait a minute, I paid a professional architect to draw these plans and it cost me $40,000. Everything should be right. Well, you're absolutely right. It should be, but it might not be. And that's the problem. Double check the measurements pertaining to all of the walls above and below. Double check and make sure the length of the stairway is actually going to fit in here. I can't tell you how many times I came to a project like this and the architect might have had a 109-inch total overall floor height difference. The measurement between the bottom level and the upper level, let's just say, was 109 inches, when in reality it was 112 inches. So this would have changed the step or the riser and then made me add another step because it wouldn't have fell into the local or met local building codes. So double check all these measurements. And I will put a link here for those interested in. I actually have another channel that I'm taking apart this house right here and showing you step by step. I'll put a link here to the stairway part of that video. Number 2 on the list, and this is probably one of the biggest mistakes professional stair builders make. They do not pay attention to the details. And again, if you're a perfectionist, you are going to be paying attention to the details. This was a lesson that it took me probably 2 or 3 years to get to realize how important it was. And that is that if you want your stairs to start and stop at an exact point, then each one of these treads need to be laid out accordingly. So here we have 7 treads and we have a 70-inch measurement. And if I was to lay each one of these out at 10 inches, I'm not going to have a problem. It's going to stop right on the money. If one of these is a 1/16 of an inch longer, or a 1/16 of an inch shorter, or a combination of both, a 1/16 of an inch longer, and then an 1/8 of an inch shorter, an 1/8 of an inch longer, an 1/8 of an inch longer, something like that, we're going to get some wacky measurements. So each one of these treads and risers needs to be laid out precisely, exact measurements. If you are dividing 5 foot, if we have 5 foot and we have 8 risers, we divide this into here, we're going to get 7.5 inches for each one of the risers. We need to lay them out at 7.5 inches, not 7 5/8, not 7 3/8, not 7 5/8 on one and 7 5/16 on another one. You know, each one of these needs to be exactly the same. And on longer stairways, it's going to be even a bigger problem. Number 3 on our list will be adjusting and compensating for building materials at the bottom and top of your stair stringers. And again, you're going to have to do this when you're laying out the stair stringer. So if I don't subtract the thickness of the tread off of the bottom of the stringer, I'm going to end up with a taller riser overall. So we've got to subtract the thickness of the tread off of the bottom of the stringer. And again, I'm just saying it. I'm not going into a lot of detail. I do have other videos on that. I'll try and find a link and put it here. And then of course the top. If you are going to add a riser, put a riser on here, everything will work out. But what if I wanted to butt the stringers, connect them to the concrete, and then have this be my last tread, and then use the concrete as the face of my riser? I would just need to deduct the desired amount off of the stringer. Now, what if I wanted to add a ledger? If that's the case, I would just simply deduct whatever I needed for the ledger off of the stringer, and then make sure that everything is going to work out accordingly. And here's what it would look like after I deducted 3/4 of an inch off of the bottom of the stringer. 6 3/4 of an inch provides us with a 7.5 inch finished riser, which would provide us with the same equal measurements for each part of the stairway. Number 4 on our list is another problem that most people don't even think about, and that will be the different size materials that you are going to use, if you are going to use them, at the bottom or throughout the stairway, and of course the top. So if I go ahead and put an inch thick tile on the bottom and then put a 1/2 inch thick material over my stairway like this, I'm going to end up with a 7-inch riser at the bottom, and then the rest of these will be 7.5 inches, and the same thing at the top. Now, if I'm going to use the same material throughout the stairway, let's say I'm going to carpet this area, everything's going to get the same carpet. I'm not going to have a problem. Everything should work out. But if you are going to use a thicker or a thinner material, either at the bottom or the top, or on top of the stairs, you're going to have to compensate for those materials when you're laying out your stair stringers or building your stairs. Next up on the list, number 5, and this mistake right here will prevent you from wasting lumber, because what you're going to do is lay out a stair stringer and then cut it. And again, you could probably do this too by just laying it out and cutting the bottom and cutting the top and double checking everything. But if you lay out the stair stringer and you cut it, put it into place, put it into the position where it is going to go in the building. And then simply double check everything. Make sure that all the steps are level. The risers are plumb if they're not going to have an undercut on them. And then make sure all of these measurements work out. Make sure that you've allowed for the ledger. Measure everything and double check it 25 times if you have to. Now, this is where you're going to notice if you did not use precise and exact measurements. So let's say that you divided everything up and you come up with our riser height of 7 9/16, but you made the riser 7.5 inches. That's going to create a tread that's not going to be perfectly level or perfectly flat. And of course, this is where you will see it. If you put the level on here and it's off just a little bit, I would recheck everything, measure your riser, measure the riser height and the tread width to make sure that everything is proportionately accurate, or as accurate as possible. I mean, if you're off a 1/16 of an inch throughout the entire measurement here, this should be right on. It should be close enough. You know, if you put the level on here and this thing is sloping down 1/8 of an inch, you might want to recut the stringer. If it's sloping up 1/8 of an inch, you might want to recut the stringer. If you only have a couple measurements that are off by a 1/16 of an inch, you might just leave it, and that's going to be close enough. So here is another thing you can do when you are building stairs, and you would actually like them to turn out as nice as they possibly can, and that would be to stack your stair stringers on top of each other before they're installed so that you can check for any imperfections. And to do that, you're either going to line the back of it up, you're going to line the front of it up, Because if your imperfections are only about 1/16 of an inch, then I wouldn't even worry about it. What you're going to be looking for will be imperfections that are going to be a little bit larger. So here you can see where everything looks good, and you've done a good job cutting your stringers at the top. And again, if this was off just a little bit at either the bottom or the top, then you can probably let it go. However, if it's off quite a bit, then you're going to need to make some adjustments to it. Or at least I would recommend that you make some adjustments to it. And you can do that by adding shims or shaped strips of lumber like we did here. And I would recommend using some type of an adhesive along with some small nails or screws to attach the shim to the stringers. And I will be making a future video to show you what happens if you don't fix this before you install your stair stringers. So here we had some imperfections that needed to be filled, and we used shims to do that. However, you could end up with an imperfection like this that needs to be trimmed. And if that happens, just simply grab your saw and recut that part of the stringer, or use a planer or some type of a sanding device to trim the wood off. Now, I've also used belt sanders to flatten some of these imperfections out also. And the last thing I would like to suggest would be that if you have too many imperfections, then you might consider recutting the stair stringers. Here is another quick tip for those of you who are cutting your stair stringers and a section of the stair stringer breaks off of your $40 or $50 piece of lumber and you're not that hip on getting rid of it. And you don't have to. Simply put some adhesive on both sides that need to connect together, place it back on, then grab some small nails and reattach the broken tip back to the stair stringer. And I've done this hundreds of times with great success. And of course, you're probably not going to have this problem if you're selecting primo lumber, number one, or a select grade of lumber for your stair stringers. However, there are a variety of other circumstances that could lead to this. And if you can save the lumber using this trick, then definitely use it. Here is another question from one of our viewers. They wanted to know how to miter the back of a tread where it connects to the riser. And most of the time you won't need to miter these two pieces together. You're going to be able to simply butt one of them up to the other, whether the riser sits on top of the tread or the tread butts up against the face of the riser. You're going to end up with the same type of look. You're going to have a line right through here, whether the two pieces are simply butting up against each other or mitered. And believe it or not, I mitered it while you weren't looking. Here we have a mitered edge and the same look. However, my guess is that the individual asking this question had another thing in mind, and that might be the fact that the bottom of the stairway was going to be exposed and they didn't want to see the two lines. They wanted to see a mitered edge. And we wouldn't have ended up with something like this if we butt the two pieces together and didn't miter it. And hopefully by taking a look at these examples, you can figure out if you need to miter the top and the bottom of the treads and risers for your particular project. And cutting miters like this aren't always easy to do. And if they're not connected securely and the lumber starts to dry and twist, you could end up with this joint separating or the gaps getting larger as the lumber shrinks to create a trip hazard. So keep that in mind also before you consider mitering your treads and risers instead of having them butt up against each other. In this video, we are going to talk about cutting grooves to create an anti-slip stair tread for an outdoor deck. And the first thing I would like to point out is that this could lead to excessive wear and something that isn't going to look very nice, especially if the grooves are placed too close together. Right here, they're about 1/8 of an inch apart, and each groove is about 1/8 of an inch wide, 1/8 of an inch deep, about the width of a saw blade. And of course, these grooves can be made by cutting a straight line And I would imagine a table saw would work a lot better than a circular saw. And of course, the reason why you're going to want to space them a little farther apart will be the fact that the smaller ones will be easier to break off, the smaller tabs or smaller pieces here in between the grooves you've cut with your table saw. So if I was going to do something like this, it might look like this, might be tempted to do something like this. However, I might want to move this back a little bit further. And what I've noticed when doing something like this is that the front section of the tread will usually wear down a little faster. And of course, this type of damage will be a little more easier to make on softer lumber than it will be if you use hardwoods. So another thing to keep in mind when selecting your lumber for your stair steps, along with the design of the grooves, the depth of the grooves, width of the grooves, and of course the width of the tabs here. So let's go ahead and wrap this video up by just kind of providing you an idea of how it can wear, even though this wouldn't be an exact replica. So if I was going to do something, I would move these grooves back a little farther, maybe an inch, and then space them possibly a ½ inch apart. And of course I have an X here because I really don't think you're going to need any more grooves. You're not going to need any grooves back here. And don't be surprised if the center of the stairway wears a little sooner than the outer edges, because that's the area that is going to be used more often. Here is something you might need to know if you are building a foundation on the side of a hill. And that, of course, will be the angle of repose. And that is a common term used by engineers. I'm just going to call it the 45-degree angle rule here. You need to make sure that a footing or a foundation, and here we just have a footing. It's a 1 foot by 1 foot footing, and the area under here needs to be undisturbed. Or if it was disturbed, it would need to be recompacted. But there actually needs to be soil here in this area. And I don't want you to get confused. You know, you can't build something on top of this and not have any soil on the side either. That's not what I'm suggesting. But you do need soil. And it will need to be kind of shaped like a pyramid here around the footing. Any area of this that does not have soil, which you'll see here in a little bit, soil or ground, whatever we have, gravel, something like that, granite, rock, any area outside of this could create a problem for your building. So here we have the footing, give you an idea what I'm talking about. Take a look at it there in an X-ray view. So here's our footing. Now this isn't concrete, this is just an area of soil. You actually need soil under the footing to transfer the load from the building. Now in this situation, the angle of repose is actually not in the soil, so this wouldn't be an acceptable situation here. Now here's a situation where you might have thought, hey, I'm going to correct this situation by backfilling some soil in here. But that might not work because this angle of repose, I don't know how far it goes, but I'm guessing it's got to be at least 100 yards long. But again, I'm just guessing here. I couldn't find any information that suggested that there was a minimum length for this at a particular angle. And of course, this would be more of a common situation where you have a sloping hillside and the angle of repose in there. And of course, here's a situation where the angle of repose would be sticking out past the side of a steeper hillside. So again, these are just the basics. You might want to do some more research on it, but I wanted to make a video kind of explaining a little bit of it to those who are working on in areas that are near steeper cliffs, let's say, or bigger slopes, the main concern for engineers is soil erosion. You build something like this, and some of this soil starts to erode back farther and farther, and pretty soon you don't have anything supporting your footings. In this video, I am going to show you what they had before the tape measure was invented. There it is, a folding ruler. And the tape measure, I think, would be the instrument of choice for most carpenters today, but this is what they used back then. You just simply folded it out in sections, butted it up against the edge of your piece of lumber. You weren't going to be hooking over anything like a tape measure, and then making your mark. There it is at 10 inches. Now let's double check it with the tape measure there. Nice, right on the money. So I checked it, I measured everything, and the only thing I could see is from tip to tip, there was, I think some rulers were 7 inches. This was about 1/8 of an inch short. So you wouldn't be able to just take the section of the ruler and mark at one end and then mark the other end. That just wouldn't be happening. So there it is. Folding ruler. If you flip it over, you have 1 through 72 inches on one side, and then you flip it over, and then you have the reverse on the other side. And this all makes sense. You're kind of thinking like, why would it be like that? But if you turn it over, you can see where it's 1 to 6 inches on each side. So that would help you if you were measuring something. You don't have to think about which side you're going to use. You can grab either side and start marking, of course. So the folding ruler there, and of course the tape measure there. Now the real question here is, how many of you have used one of these before? Now I personally have never used one. I got this off of the internet and bought it for the sole purpose of making a video to show people about them. I've heard about them, heard people using them before, but if you have used one, then I would love to hear your reasoning behind it, why you used one of these instead of a tape measure. In this video, I will provide you with a simplified version or explanation from the 2018 International Building Code Book of what's actually required for, or to figure out the width and depth of a stair landing. Now, the first thing they point out is that a stair landing is at the top and the bottom of the stairway, and that it needs to be the same depth as the width of the stairway. So this is important. There's only going to be one exception to this rule, and that's when we get to stairways larger than 48 inches wide. So if you have a single family home, which I would imagine the bulk of the people watching this video are looking for information for the homes that they live in, or maybe something you're remodeling or building. Now, I need to point out that this information isn't going to be accepted all the time by your local building authorities, your building department. So if you're building something new or remodeling something, always check with them to make sure that what they require, because if they change a little bit, then you could be in for a nightmare. And I also need to point out that there are so many rules and regulations in the building codes that some of the people who check the plans don't always check certain things. In their mind, they have certain measurements locked in, and so they might not be checking it. And these building codes might not have applied to those stairs built in the past, but might apply to the stairs built in the future. So when you go to someone's house and you say, wait a minute, this doesn't work here, that's fine. But these building codes from the 2018 International Building Code Book look like they might have changed. So let's go ahead and get started. If you live in a home, single family home, or a building with an occupant load of less than 50 people, then 36 inches by 36 inches, 3 foot by 3 foot at the bottom will be a minimum. The stair width is 36 inches wide, 36 inches deep. And at the top, you would need the same distance, 3 foot minimum, 3 foot in depth. It can be bigger, just can't be smaller. Now, these measurements are going to change if you come to a public building or a building with an occupant load of more than 50. And of course, that means that the minimum width on a stairway is going to now change to 44 inches or 3 foot 8, bringing the depth of the landing to 3 foot 8 inches also. So single family homes is probably not going to apply to you, but this will to practically every other stairway built. So again, 44 inches at a landing that's in the stairway by 44 inches. And of course, at the bottom, it will be the same also. Now, here's something else that can be a little confusing, and I hope I don't make it more confusing, but 4 foot, 48 inches is kind of a minimum maximum or a maximum minimum for a stairway. And to make it simplify it as simple as I can possibly do it, any stairways wider than 4 foot wide, any stairways with a width larger than 48 inches, do not require you to go the same depth, to use the same measurement as the width of the stairway for your landing depth. 4 foot is fine, so it cannot be smaller than 48 inches. Even if the stairway is wider than 4 foot. So if I had a 5 foot wide stairway, I can use a 4 foot depth. It does not need to be 5 feet. I mean, if you could imagine this, what if I had a 10 foot stairway? Does it need to be 10 foot deep? Would I need a 10 foot long, landing? If this was 10 foot wide, no, I could go to a 4 foot wide stairway and go all the way up. Now, if you were going to build a stairway that's 10 foot wide and then come to a landing and have a 10 foot landing with a 10 foot wide stairway, they're not going to have a problem with that because that's going to be well above the minimum measurement of 4 foot. So I hope that makes sense. So if I had a stairway that was 4 foot 1 inches wide, 49 inches, 4 foot 1, then this could be 4 foot. It does not need to be the same width and depth. We don't need to use the same measurement for that. And of course, that is all the way through the stairway. Another building code you might need to familiarize yourself with will be any stairways with a vertical height longer than 12 feet will need a landing in them. So here we have basically 13 feet, 1.5 inches from the ground to the landing. Stairway like this will not be acceptable. You will need to have a landing in that stairway. So the width of the stairway or the depth needs to be the same or larger than the width of the stairway. Now, I would definitely check with your local building authorities for this one here because I remember, and I just thinking out loud here, this used to be 48 inches and they could have changed it and it might not have ever been 48 inches, but I would definitely check with them. Now, the reason for this, I think if you've watched some of my videos recently, you would know, is that if someone was to fall down the stairway, then they're going to fall and stop at the landing. If you fall down from the top of a stairway like this, you could actually fall all the way down the stairway. So that's the reason why they want this particular building code. And of course, a lot of times, once it's explained and makes sense to you, you're going to be more susceptible to do it because it makes sense safety-wise. And thanks for watching. To learn more about home building and repairs, visit us at our website. Also, don't forget to subscribe for more awesome content. See you next time.